Assalamualaikum. Today I will represent our group for this group project MAT300 Ordinary Differential Equations. Before I start the presentation, I will introduce our group members. Start from top left, Sarah Atira binti Muhammad Zahari, followed by Farah Syuhada binti Suhairi, Nurul Husnina Amani binti Abdul Halim. On the bottom right, Nur Syafika Aisyah binti Abdul Ghani, and finally myself, Muhammad Shakir bin Abdul Razak. I start with introduction to problem. A differential equation, ordinary differential equations, ODE, if an equation contains only ordinary derivatives of one or more dependent variables with respect to a single independent variable. Now I move on to the application of first ordinary differential equation. There has 5 applications of first ODE, which is population growth, radioactive decay, Newton's law of cooling or heating, electric circuit, and Mr. Problem. For the topic of our group project, we decide to choose Mr. Problem as application of first ODE. So mixtures are the mixing of two fluids sometimes gives rise to a linear first order differential equation. Also, mixing problems are an application of separable differential equations based on the concentration of a substance in a tank. This is a situation that we create about the mixture problem. So the situation is Sabri always do water disinfection on the tank at his house every 3 months to make sure that they can clean water while checking whether the tank has no leak. He also wants to know when the tank will be overflow or empty so that he can identify the destroyed parts in the tank easily. The 150 gallons tank holds 100 gallons of purified water that contains 50 pounds of soluble substance is dissolved in it. He put household bleach with 1.5 ppm of chlorine per gallon leaks into the tank at 4 gallons per minute to disinfect water in the tanks. The mixture in the tank is perfectly mixed and it flows out of the tank at 3 gallons per minute. Post printed or PS. Write a model AT for the amount of salt in the tank at the time T. Find out when the solution is about to overflow and determine when the tank will be empty if the rate of chlorine leaks in the tank is changed to 2 gallons per minute. Next, I will explain about formulation of model and method of solution. Assume a tank initially contains VO liters of solution where AO grams of substance A is dissolved. Another solution with concentration of C1 grams per liter is filled into the tank at the rate of R1 liter per second. The solution is then well stirred and is pumped out of the tank at the rate of R2 liter per second. The graphical representation of this situation is shown below. Inflow rate into the solution equals to R1 liter per minute. Concentration equals to C1 gram per liter. VO of solution, AO of substance A. A0 equals to AO. Outflow rate into the solution equals to R1 liter per minute. Moreover, let AT denote the amount of substance A in the tank at any time. VT denotes the volume of the solution in the tank at any time. VT equals to initial volume of solution in the tank plus volume of solution enters the tank minus volume of solution leaves the tank. Vt equals to Vo plus R1T minus R2T. The rate of change of the amount of the substance A in the tank, dA over dt, is given by dA over dt equals to input rate of substance A minus output rate of substance A. dA over dt equals to C1R1 minus C2R2. dA over dt equals to C1R1 minus A over V times Vt R2, or dA over dt plus R2 over dt times A equals to C1R1. I move on to solution result. As you can see, this is a situation that I explained before. So move on to the next one. I will explain the solution more details. Write a model AT for the amount of the salt in the tank at time Vt equals to Vo plus R1T plus R2T. C2 equals to AT over Vt equals to AT over 100 plus T equal to 100 plus 40 minus 3T, and equals to 100 plus T. dA over dt equals to C1R1 plus C2R2 equals to 1.5 times 4 plus 80 over 100 plus T times 3 equals to 6 minus 3AT over 100 plus T. Hence, the model is dA over dt plus 3 over 100 plus T times A equals to 6. E power of to integrate 3 over 100 plus T equals to E power of to 3 ln 100 plus T equals to 100 plus T power of 3. 100 plus T power of 3 dA over dt plus 3 over 100 plus T times A equals to 6 times 100 plus 3 power of 3. dE over dt times 100 plus 3 power of 3A equals to 6 times 100 plus T power of 3. Integrate d over dt times 100 plus 3 power of 3A dt equals to integrate 6 times 100 plus 3 power of 3 dt. Let u equals to 100 over plus t, du dt equals to 1, du equals to dt. 100 plus 3 power of 3a equals to integrate 6u power of 3 du. 100 plus 3 power of 3a equals to 6 times u power of 4 over 4 plus c. 100 plus t power of 3a equals to 3 over 2u power of 4 plus c. 100 plus t power of 3a equals to 3 over 2. 100 plus t power of 4 plus c. A equals to 3 times 100 plus t over 2 plus c over 100 plus t power of 3. T equals to 3 times 100 plus t over 2 plus c over 100 plus t power of 3. Find out when the solution is about to overflow. Vt equals to 150, 100 plus 30 equals to 150. T equals to 50 minutes. Hence, the tank will overflow at T is 50 minutes. Determine when the tank will be empty. If the rate of chlorine leaks in the tank is changed to 2 gallons per minute, Vt equals to 100 plus 2T minus 3T. Vt equals to 100 minus T. Vt equals to 0. 100 minus T equals to 0. T equals to 100 minutes or 1 hour 40 minutes. Finally, summary and discussion of solution. Discussion. Based on the situation created, we also think that it can relate to the process of swimming pool sanitation, where it is the process of ensuring healthy conditions in swimming pool. The method is still the same, where they put chemical substance known as chlorine to disinfect the dirty water that full of germs because it have been used by many people. The proper step to sanitize the pool is needed, and understanding the role of chlorine in maintaining safe water is very important. Therefore, the swimming pool's water will then stay clear of algae, free of toxins causing pathogens, and user won't complain about red eyes or chlorine smell. The result. Based on the information we have in Sabri's situation, the initial volume of solution in the 150 gallons tank is 100 gallons that contains 0 concentrations. Before purified water is used, 50 pounds of soluble substance is dissolved in the purified water, and the solution now contains 1.5 pounds of concentration. After calculation done, the information that Sabri to solve his tank's problem are the time taken for the solution is about to overflow is 50 minutes. In other words, the solution will continue to flow out of the tank at the rate of 3 gallons per minute. Next, the time taken for the tank will be completely empty when the rate of chlorine leaks. If the tank is changed to 2 gallons per minute, is 1 hour 40 minutes. With all of this information, we can solve Sabri's problem. Before I end the presentation, we would like to thank you to our lecturer, Madam Jasmani binti Vidin, to give us opportunity to present for this group project. That's all from me. Thank you and Assalamualaikum.